programmer, then this video is for you. And you know that nowadays the programming is an integral part of machine learning. So without that, you cannot be successful in your discipline. So we will talk about a very important topic that is called program correctness. What is program correctness? But first, let me tell you about one disastrous event that occurred in 1962. What happened in that event is that was Mariner 1 spacecraft. It was launched by NASA and to measure some calculation, maybe some other things as well in the space. So what happened was that after 290 seconds, almost 3 minutes or 4 minutes, something like that. After 3 to 4 minutes, this space shuttle was destroyed or exploded in the. It was actually intentionally destroyed in the space. The reason was when it was traveling in the space, the path the spacecraft has to take was this one, but it was taking this path. So it was actually going away from its path, and the reason was the programming error. There was a programming that was guiding this spacecraft to move into the space and reach somewhere. So there was a programming error, and but what that programming error was, there was a hyphen missing in the program. Hyphen was put it in the velocity to tell us that this is average velocity, but it was not actually measuring. It was not measuring the average speed, but it was measuring the actual velocity. So that is a technical thing. But the question remains the same, that the spacecraft was destroyed after 290 seconds due to the programming event, due to the programming error. Now, look at the another example. If you are a programmer and working for some bank, for example, and they gave you a task to write a program for their ATM machine, for some, you write general program for every ATM machine of their banks. So if you have written a wrong code and some person, for example, withdraw some cash, and he or she uh, press rupees 10,000, and but instead of 10,000 withdrawal, you get 20,000 rupees. So it means that there is some error. Now excluding all the uh, hardware thing, we suspect that the programming error is the main thing. So there must be some programming error that actually reads not 10,000 but 20,000. So it becomes a very important aspect of programmer to have a correct code, and that is the topic of this video. So program correctness is a tiny thing that gives you confidence in your program. So first of all, uh, when you say that when the program is correct, a program is correct when it has valid input. I'm not going to write the exact definition. You can see that in the Rosen book. It has valid input, then you get expected what you are expecting, and you get the same answer, that is expected outcome or expected output for your input. Then we say that the program is correct. Now the question is, how can we say that the program is correct? For example, you have written a code of 1,000 lines. To see that this program is correct, you have to read all 1,000 lines. It is the case sometime, but there should be some efficient way to read the code as well. So what we do, we these 1,000 lines, we uh, make some small program, and these are called the partial program. I mean, we pick out the small program. For example, we pick first 5 lines, then we pick line number 6 to 10, and so on. So we make partial program. Now what happens is, you want to check these small chunks of your program and want to see either this is giving a correct response, a correct answer. So we must give some input, and that input is called the initial assertion. Here we put assertion, initial assertion. I just remove the second part. So this is your small program. This is your program. Initial assertion. And that initial assertion, the name of that, we usually call it P. Then at the output, what we expect, that is called final assertion. That is called final assertion. So that is your final assertion. And where is the program? The program is, usually we call that S. So what we have in any program is the initial assertion. Then we have final assertion, and in between we have some program. Okay, let me just show you with example what we mean by that. And what we mean by that, let me just first write some symbolic way of writing this process. So we have initial assertion, we have program that is called S. So usually we write this as P as initial assertion. Then symbolically we start with curly braces. S. S means the program itself. It is S. And then we have as an output, which is final assertion, and the output is your expected value, expected answer. So let me just start with some simple example. 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 Suppose we have a program written in any language, y is equal to 1, and then we have z is equal to x plus y. And you have to prove that the program is correct. We have to prove that the program gives you expected answer. Program is correct when x is equal to 0. So we identify all the processes or the ingredients of this partial program. It is only one two-liner code, so there should not be many sub-programs. So initial assertion is, in this case, initial assertion is, which is x is equal to 0. That is your called P. Now what is S over here? So what is S over here? S is your program. S is your program. So S is y is equal to 1, z is equal to x plus y. Remember that this colon and equal is just a theoretical way of writing a program. And then this is your S, and what is the final assertion? And the final assertion is what should be final assertion when this x, when we have x is equal to 0 and y is equal to 1, and we put these values over here, 0 plus y is equal to 1, and then we have z is equal to 1. So the question actually is, program is correct when x is equal to 0 and we get z is equal to 1. That is your actual question. So you are expecting that z should be 1. So final assertion that was required, it is z is equal to 1. That is your q. So this part is s, the initial one is p, and then we have final assertion. So it is true. Okay. So your code is correct for this program. Now, now the question is, as I already talked about, if you have 1400 line code, 1400 line code, how can you check that the program is correct? So you make a small chunks. So you have for every chunk of your program, you have initialization P, then we have S. This is S1 since we are talking about the first chunk. Then we have Q. For second case, this is your program, the part of your second program, and this output will go to that program. So we have Q, and we expect that we will get R over here. So in this case, the notation becomes, in first case, the notation is P, curly braces S1, then we have Q. For second S2, we have Q S2, and we have output R. And finally, the conclusion we can draw is P S1. This whole process, for this whole process, we have S1 semicolon S2, and we expect that the answer should be R. So this is called the composition rule. This is called composition rule. Composition rule. Thank you for watching.